Hi guys, my name is Joe from BODAN. Thank you for watching our first episode podcast. This is BODAN's podcast. It's about GTR topic in general, and we're going to talk about engineering, electronics, tuning, and car enthusiasts with the cars. So let's get straight to it, and I'll start letting this gentleman on the left.
All right, let me introduce myself. I'm Radek Pasina. I'm an avid car nut ever since I was young and have spent most of my working career in OEM automotive doing embedded software, and then also some time in medical devices, and now working on the embedded software and a bit of project management stuff within the motorsport space on the ECUs. So that's me.
Thank you.
And I'm Lee Burley, Director of Melbourne Performance Centre, also MPC Auto Speed and Audi Sport Customer Racing in Australia. Obviously my main job within my business is tuning. That's what I have the most experience with and what I'm doing. So yeah, really keen to talk to you about tuning.
My name is Joe from BODAN. I work from many different sectors in the last 25 years of my career, starting with defence and then and doing a bit of industrial. But I always had passion for cars, and a few years ago I decided to pursue my vision and dream about my beloved GTR platform and start developing product with great gentleman here, Lee Burley, to offer some of these products out there.
I'm James. I'm literally the guinea pig of everything. My bank account is zero because Joe keeps giving me stuff that breaks my car, like in a good way, like gearboxes. Obviously too much power, but
I don't remember I saw your gearbox.
yeah.
Funny.
Look, we'll get that's a story for a different day. Anyway, so I do all the R&D on the street because Joe just likes giving me toys to play with, and I just push them to the limit. So yeah, look, it's fun and all. The result's always good, in a way.
Oh, wow.
It's usually just gearboxes. I think it's just gearboxes. We'll put that down. We'll put that down to that. Motor is 100%. Lee tuned it. It's grouse. Lights up the tyres. Does all the fun stuff on the track. So, yeah, cool. Well, let's get into it, eh?
Look, privileged to have this gentleman here, and let's get straight into it. I'll pass on to Lee. Just tell me a bit about MPC and Auto Speed.
Yeah, so I'm Lee Burley, Director of Melbourne Performance Centre and our subsidiary company MPC Auto Speed. So we're celebrating our 20th year in business this year, and really like the start of my business was tarmac rallying, and we actually did a lot of GTR Skylines from R32, R33, R34 Skylines back in the day before even R35 was thought about, I imagine. So had a lot of early time with GTRs, and it's really, I have a bit of a passion for them. It's probably my favourite car, and Nissans in general. So that, and then we've sort of gone away from that a little bit. Customer base did other things, but we've just come back. There's obviously a resurgence of GTRs in Australia. The scene's getting very big, so yeah, had the opportunity to do some R&D and development with Joe and BODAN. So yeah, bringing really back to my roots with the GTRs. So yeah, the last couple of years again, sort of back on GTRs. Obviously a lot more experience from when I was doing GTRs back in the day, and technology's really moved in with Motec ECUs have really progressed. Particularly with speed, processor speed, which allows you to do stuff much more accurately, and then software, it's really an open book now what you can achieve with the ECU, whereas back in the day 15 years ago we were sort of restricted to certain parameters. So it's really exciting times for me because it's a passion with the car. I really enjoy it, and new products like I'm learning stuff again, particularly with some of the products BODAN's got. Right at the moment, coil packs is something we've been working on, and yeah, I'm seeing stuff that I never thought I would see. So that's really interesting and really sparked my interest. But yeah, really enjoyed working with Joe, his passion for the product, and yeah, even some of the results we got the other day testing on the dyno, your excitement levels really shows
it was
passion.
quite a shock.
Yeah.
It was quite a shock, some of the testings we've done, and I have to admit that I am, once again, very privileged to work with such a knowledgeable gentleman here with such vast range of knowledge in tuning, racing, and have some of the fundamental understanding of how internal combustion engine works, which is where I also very passionate about to think outside the box and to think what can we do to make the platform better. And I'm also, same with James and yourself, and to a degree Riddick as well, really passionate about cars in general, especially with GTRs. And back in the days when I was at uni, and I would never dreamed of able to afford one. And here we are, and working with one of the most experienced GTR tuner, and also we tried to work with Motec and get the Motec system to the platform, and it is a very exciting time.
Yeah.
And can you tell me a bit more? You recently tuned a Group A, one of the root of GTR 32 GTR Barvis car, the 001, 002, which was quite opening compared to what it is now.
Yeah.
Can you share a bit of light on it?
So yeah, Gibson Motorsport cars, the R32 Godzillas. I have the privilege of tuning I think there's 5 GDRs and then also the GTS cars. So yeah, even down to the Bluebirds and the Nissan Exa. So yeah, I have been tuning them for numerous years, and obviously with technology there was limitations of ECU again with those. So historic racing has sort of allowed Motecs to be involved. It's not like a standout. They show the Motec, they're all hidden away, but it's not cheating. It's known just because the technology and electronics back then, they're lucky to sort of switch on. It's like switching on your old.
I saw that car I saw the car in person. The electronic box was that big.
Yeah.
It was like literally a carry case, bigger than carry case. And now look at the size of the box. It's quite a major leap.
Yeah. No, it is huge, and you can fit a lot of stuff in that case, which is lucky. But yeah, that's been really enjoyable, and there really was good technology and some smart people building those cars, because they do make. They're not making astronomical numbers now that everyone's chasing, but for a circuit car that does the Bathurst 1000 or 500 at the time, they're really good cars and really well built. The money was exceptional there with cigarette money.
Yeah,
so
it was quite extraordinary seeing the car in person, and the level of execution and the attention to the details back in early 90s. That was something, in today's standard, was extraordinary.
Yeah, and the money spent in development on engine dyno, like I know a couple of the guys that originally did the development, and that was the first I ever heard and knew of basically looking at cylinder pressure. So getting sensors at the time, and obviously they're affordable these days, but back in that day you're paying, I don't know, $50,000, $60,000 for a sensor back in that day. And they, I'd spoken to Steve Curtis about that in the way he was using that to detect knock and so forth, and it was very interesting. But I sort of, back 20 years ago, never thought I would sort of be able to afford that, or it's not so much afford it, but make it cost effective in my business to spend that sort of money just to get that. But nowadays, those sensors and that are available, like they're cost effective, and it opens up a new way of tuning and learning what happens inside the engine.
It is certainly very exciting when you actually think about the internal combustion engine, and every step, from the moment you draw in the air to the compressing the air, the fuel get mixture, and then the cylinder pressure peaks up. And there's a lot of things happening. You can't physically, like a car, like making something. You have to process a lot of information, the image, with a lot of fundamental understanding of the work, and then combining with the modern sensors and electronics to be able to visualize to get the results is...
Exactly. It's no good just having the sensors and spending all the money on the stuff to do it. You really need to understand the physics behind it and how it works. And I won't say I know everything. I think I know a lot and have had a lot of experience in a variety of cars. So I think that's the best thing when you stick to, if I just did GTRs or RB engines, I'd be a bit restricted in what I was able to learn. But yeah, over the years, done a lot of different engines for different purposes. And I've always said, and the advice I've given to young mechanics is be a sponge. Never think you know anything. Always listen, be a sponge and try and get as much information as you can.
That's very good advice.
And then you decipher what was valid information and not. But if you're one of those people that goes, no, I know what I'm doing, I don't want to listen to you, you never know that person could have something that just triggers you and you go, oh, I never thought of that.
That's actually, love that these days, and I truly respect what you just said. You know, I'm that kind of person too,
Yeah.
and I want to learn, I want to listen, I want to listen from a different perspective. And that's the whole reason we're having this talk today, is to share knowledge, you know, and encourage people to have the open-minded, to have being a sponge, like you said, and to be able to observe the knowledge and learn from each other to grow the community. And that's the whole, you know, I think the goal of this this channel. No, thank you very much for that. I'll take it on to really, you know, as an electronic software development expert, being in the OE world and automotive world. Now you're in the racing world. You know, can you take us a bit more in depth on, you know, what do you see in terms of fundamental electronics? How does it help in terms of getting the car where we are, and also in the software side, and where do you see it's going into the future, and in terms of internal combustion engine? And I think that's the passion we have, internal combustion. We like the electric cars, but I think just the internal combustion has got that beauty in the arts in there. Can you take us a bit more about on that aspect?
Yeah, absolutely. Yeah, I guess you sort of have to start back at the start, essentially, don't you? When aftermarket ECUs sort of came to the market, and Motec was actually, you know, it's kind of very appropriate because it was one of the big ones that sort of came onto the scene quite early, you know, 30, 35 odd years ago. And there was a few other players at the time as well, you know, like you had the Microtechs and the Wolfs and a few others. And for me, it coincided with the time in my life where I was influenced by my dad. I was just getting my L plates and always into computers. And so started modifying cars and put on a Microtech on my first car. My brother, he put on the Wolf on his car.
Wolf. I still remember the Wolf ECU. That's old school. Was it before your time, James?
No, we put them in VLs back then.
Oh yeah, we are.
Yeah, it was the bee's knees for a VL.
Yeah, and it was a great time. I loved that time. But you know, now then I start working. Originally, I was actually not even meant to be working in automotive, even though that's what passion was. It was more meant to be in mobile, bringing internet to mobiles, but that all shut down in Australia. So it's like follow the passion. But ultimately, it's been great and it's been eye-opening. And you look at where things have gone. You know, you're talking back in the day, it was like an 8-bit micro, really slow. Maybe it was running at 16 megahertz or so, and the amount of processing you can do in that time is quite small. Like, you know, you think of what running a V8 actually needs. Like, you know, when you're running at 9,000 RPM and you're trying to manage your knock, which usually requires fast Fourier transform interpretation of the signal to work out, you know, which cylinder it is, and then at the same time you're looking at your crank signal, your cam signal, and you're trying to synchronize that, which all has to be precision control with your injectors and your ignition. And you know, that's like your bare basics. There's so much more in the cars, right? You've got your map sensors and MAF and everything else, and even that's all still basic. And all of a sudden you realize, man, every single second I have to process thousands upon thousands upon thousands of bits of information compute them and then determine the value. And, back in the olden days, that was all done by, 2D maps, and it was always a compromise. It was better than a carby, but it was a compromise, right?
It's like throw a ball, let's see where it lands, the kind of thing, is it?
Yeah, exactly. Like you get it perfect on idle, and then it was shit in the top end or bad in the top end, and then ultimately, it was good to watch it over the years. So quite a lot of my time, I was in OEM, but not on the ECUs, but I was at least playing with cars on the side, and then, more recently in the motorsport sector for the ECUs, and you had the progression away from the old fuel injector timing-based maps to the volumetric efficiency maps, and all of a sudden that was like a world game changer. And
Yeah, that was something new, volumetric efficiency.
Yes.
That was quite eye-opening in the training world.
It was. It changed everything. It changed the ease of being able to get a nice tune that worked in almost every single circumstance. It wasn't this juggling act of I just based on temperature here, and then I change the timing here, and then based on pressure, and then all of a sudden it all falls over in another circumstance. So, that was sort of that was one big leap, but ultimately there was many leaps. Like sensors got better, the ECUs got so much faster. But even then, you look at the ECUs now, even say, such as the Motec, where a lot of you have a lot of flexibility where, a lot of the pins you can reconfigure to do different things. So it means that down on the hardware level, you need a lot of flexibility. But then there's a lot of really fast signal processing and really fast logging. And ultimately, it means you sometimes don't even have enough processing time. Like I think Motec's using something like this generation, something like around 150 odd megahertz CPU or so. Even then, everything you want to process isn't enough. So you end up delving into what is kind of known as FPGAs, field programmable grid array, where basically you can customize a little bit of silicon to do, bit of sampling or signal processing
This
for
really
you.
comes down to the fundamentals of designing a circuit, which I did experience the other day. I tried to rig up some sort of electronics on the programming, try to simulate a voltage signal for the four-wheel drive system. But it was quite a challenging task because the ECU or the microchip was naturally not designed to perform a duty cycle task. And what I had to do is program in a way to simulate and calculate based on the signal's input. And it was getting all kind of faults, and it was just the ECU is not designed for it, or the microchip is not designed for it, and which I explained to Lee. And then we need something that is actually fundamentally designed for it to be able to cope with the task easily. Now, can I ask you, because you mentioned about ECU speed, I remember some ECU manufacturers saying that, the ECU is nowadays so fast, it can do it while it's asleep. Is that a true comment, or is that an inaccurate comment?
Well, yeah. It doesn't cost you much now to buy a quad-core 1 gigahertz CPU and make that into an embedded device. But the thing is, ultimately, a lot of those really high-end CPUs are so complex that they require an operating system, and most of the time you end up going like Linux or something, which isn't real-time. So then a lot of the CPUs now have got like what they call a real-time core, which is a small kind of embedded core.
So just for the audience, can you explain about why you talk about Linux and what's the core, what's the difference between the two? Just for the audience, a bit more understanding.
Like you think of your electronic devices, like you think of your mobile phone, that's got a very fast multi-core CPU in it, multi-processor most times. But the thing is, it doesn't have to do anything real-time. It doesn't have to look at your crank signal and exactly at a precise moment fire your injectors for a certain period of time in your ignition. So therefore, it's okay if things take a millisecond or 2 milliseconds or 5 milliseconds. Or,
And
or
in
100.
the engine, that could be a catastrophic failure.
Yeah, exactly. 9,000 RPM and you've got a 2,500 horsepower car, you can blow things up really easy, right? So,
Yeah, there's this thin hair, a very fine line between a catastrophic failure or the car goes down the straight.
Yeah, yeah. So that's where, even though we're getting faster processors, you still have to maintain real-time control. And
So let me phrase, so the real time meaning down to the fundamental of electronic clocking
yeah,
to reference all the signal to the electronic clocking. So each pulses to reference to that clocking. And when you mention about Linux is an architect, software architect built upon that, which shields away the actual clocking, masking and then you're not actually accessing the fundamental electronics. Is that my understanding is correct?
yeah, that's right. So there are adaptions nowadays in Linux where they do try and provide a real-time interface. But you think of your phone, you think of your PC, your Windows PC, your iMac or whatever. It doesn't matter. All of them, they have to do a lot at once. Like, you've got your word processor up, your web browser and so forth. And therefore, there's only so much CPU time. How do you manage it? The CPU goes, well, ultimately, it doesn't matter if you have to wait a second for this, and then I'll process that. So there's no guarantee things will happen when you ask them. But it doesn't matter because your use case doesn't care if it doesn't happen instantly when you ask for it.
Cool. All right. Where do you see in future of electronic development for the automotive race cars? I mean, for example, would I get another 100 horsepower 10 years later for the same setup?
Look, I think a lot of that comes down to just everything getting smarter and smarter and faster, trying to vaporize the fuel more and more and stuff like that, right? So everything becomes running at higher pressures and becomes even far more sensitive than what it is today. I think from the CPU side, they're getting so fast even as it is, but ultimately what you'll always see is you're trying to offload as much as you can into the silicon, so you're not actually processing it in your own time. And instead you're sort of processing in what I was mentioning before, is like your FPGA, so that's doing all the signal gathering and a little bit of processing, and then your CPU is just sort of synchronizing it every now and then. So it's kind of allowing the full real-time stuff happening down there, and then the stuff that's less sensitive is up here. So you'll see more and more of an evolution to that. That also lends itself really nicely where CPUs or ECUs like this one, where it allows reconfiguring of pins, where you can actually reconfigure that silicon, and it means that you can start to do upgrades to stuff that doesn't exist yet. So for example, you might have USB 2.0 out. I know we're on USB 3.0. So you might have USB 3.0 now, and if you implement that in, say, like an FPGA, and then all of a sudden USB 4.0 comes out, you could actually write the FPGA to handle
okay. So you're getting the direct access to the silicon level of the controls.
Yeah, exactly. So you can sort of emulate what would normally be hard built into the micro, and therefore you could create it, which also means that it means that all of a sudden
Hopefully it's
you
not
can
too hard
change
for you as a
pins
car
to be
enthusiast.
I think my brain's melting a little bit.
Okay.
I stayed at school for a bit.
All right, so I'll throw back to you. Now, James, you've been in the GTR community for long and multiple different street racing, and then
Street racing, are you talking about?
like the mud street, like legal racing.
Legal racing, yeah.
Legal racing. Now, as an enthusiast, car enthusiast, where do you see your enjoyment, or where do you enjoy the most in the community? And obviously we try to build a good community here.
Yeah.
What's your I guess I'll give you an open page.
I mean, like, it's pretty cool to like run the old school setup and still push power. Obviously, everyone just goes single turbo. It's easier just to go single turbo. It's cheaper to go single turbo.
Yeah, that's good.
The technology's out there.
Yeah.
That's all fun, but if you're going to street drive the car, unless you've got an engineer certificate with the big boy single, yeah, you're not going to have a fun time.
That's an interesting point. I think the big single sort of conversion era starts 2015.
Yeah.
Sort of starting from that, that era, and then
look,
everyone just evolved. Boom.
I mean,
And RB has to be big single. RB big single.
Yeah. I think look, it's definitely everyone's choice. Like I'm going to say, I'll put it out there. It's like a 80% chance everyone will just say single over twins, just because like it's old tech, man.
Yep.
Obviously, we're in development at the moment with we're on 7s at the moment. They're a bit tired, so we've stepped up to like a Dash 7. Obviously, do a bit of recall.
For the audience don't know what the Dash 7 is.
Okay, Dash 7's like your base upgrade from like your ceramic turbo, pretty much.
From the GTR.
It's like an entry level.
Entry level.
But yeah, look, we've pushed out some crazy power out of Dash 7s.
And we have some successful gains, just a simple upgrades.
Just from spark plugs, like obviously gapping of the plug and coil packs, trigger kits, anything to get back to the ECU to talk a bit quicker.
Just for the audience not sure about the trigger kit, and I'll forward the question to Lee.
Yeah.
Why do we need a trigger kit?
Well, we're talking about how fast and stuff ECUs are, but it needs to be consistent and good signal. So a good trigger kit, obviously the standard.
That's a trigger kit here for those not sure about what trigger kit is. So it's to cut you.
Yeah, but the standard, they have a 360 pulse ref and then a 6 pulse sync. And you have, everyone knows, replacing crank angle sensors, they're faulty, they're not accurate. You've got free play between the the front of the camshaft and the crank angle sensor. So a lot of inaccuracies on that, from accelerating to decelerating. You're getting different.
I noticed straight away from swapping out the old trigger kit that we had. We couldn't figure out the issue, what was going on. It was just cutting out after 8,000 RPM.
Yep.
Like, I think it was the ECU just safeguarding the motor. We ended up putting on the BODAN trigger kit. This is the 12-tooth one we ended up going. Literally fixed it. Smooth drivability. You ended up tuning that. I couldn't believe it. And just like, obviously we changed the coil pack system as well with a 1.1 gap. Massive gains. Like just street driving, crazy. But yeah, look, I think we've maxed those turbos out. We've got one more test to do. I kind of want to hurt the
Your turbo is crying.
Yeah, I mean, they're smoky now. So, I mean, it's been 5-6 years on 22 PSI.
You're driving. How many gearbox you gone through?
I don't know. You can ask the missus that one.
I did ask that question.
Look, it's up there. It's over 10. I think we did 7 in like.
I think you're the most.
Everyone's gonna say driver area, but we changed the clutch and it ended up fixing the issue. But yeah, I'm not gonna say which clutch, but. But no, look, it comes on hard. It slingshots. You do the old cheeky brake boost. You surprise people. But I think, look, if I can make over 400 on Dash 7, like it's unheard of. It's a Frankenstein build. It's not a stock mode. Everyone's like, you can't do it. We've already pushed like some stupid numbers up there. You've seen how aggressive it comes on. I think it's got that little bit more in it from
I totally agree
from Joe's little secret sauce.
I was looking a little bit more to have.
Yeah, I'll tell you what. I'm gonna take the semis off, so stop like turning to butter and put something old and hard on there. So
let's get your car.
Get a proper figure.
Looking at your car, I think we'll easily achieve 400 plus.
Yeah, I mean, if it could make it like it made reasonable power on your dyno. I'm all about experimenting over different dynos. I'm not just going to favour one. I took it back to it like RE Motorsport, where it originally gets tuned. It showed, I think it was like a 28 kilowatt or something like that.
28, yeah, just straight off the bat, no change on tune.
Yeah.
Depending on the trigger kit, as a designer for the trigger kit, to me is, I call it the pathway to success. So if you do every single part to 100, even 120%, to think about what can go wrong, and as you're building up your architecture, your electronics, your everything, if you do everything in 100%, your pathway to success to your goal is a lot wider compared to, oh, I'll just cut corner here. I'll just make it easy here.
Yeah.
And then your pathway becomes narrower and narrower in a way that you almost have to play, dancing in the tower, sort of like that to make it work. Is that?
Yeah, well, it's the thinking, and a lot of the discussions we have when you're talking about new products and even current products in development is thinking of all the cases, what could happen.
Yes.
So you might have a train of thought that this is what conditions it have, and I throw in but have you thought about when this happens?
And I do appreciate
yeah,
your
and
comment. And
it's those discussions and you being very open to it. You're never that guy that goes, no, I know what I'm doing. I don't think you've ever said that in your life, I don't reckon.
no, I will never said that in my life.
Yeah,
and
which
that's probably-
although you sure in 99% of the stuff you do know what you're doing, but you're just open for information, and that we have big discussions, and normally too longer discussions, and I have to go back and make some
your
money
precious
eventually.
time
But,
is, I'm sure you're the only way
but
more than me.
I really like everything you're designing and stuff. You're getting a process, and obviously I know the things that are possibly coming up in the future, and you're really getting on that design process, the whole from idea to design to R&D, make it the best thing it can, then prove that it's going to last, prove that it can handle the conditions, and then put it to sale. So, and you're doing a really good job at that. And once you've got that process, you can almost sort of get in, and if you've got the right people around you, any product, whether it's electronics, whether it's CNC machining, once you've got that system in place to come from conception to a sold product, and you've got that great idea. So I'm sort of excited what you're going to come up in the future.
Thank you. I think a lot comes down to the heart when I see people. It's not quite often when I look at people. It's not about what they're capable of. It's not what the skill is. The heart is the the input, and the person itself is willing to open to discussions and challenge the existings. And question mark. For example, we just had a discussion the other day about knock. What is knock? Why does knock? Can there be no knock? Can we make it no knock? All those questions can actually spark your chain of thought to come up with an approach to a problem. Whether it's an engine, whether it's something, and I quite fascinating. In-depth discussions like that, and just and I quite enjoyed it. Especially talking to this guy quite some time.
Bro, like 10 o'clock at night time, I'm sitting there going through Marketplace. I'm like, what should
John,
I
can you
buy?
do this?
Spare gearboxes, whatever. I'm like, Joe's active. What are you doing, Joe? Sends me like a 3D print. He's just developing something that I'm like, why? He's like, but I can make this better. I'm like, brother, I'll just finish off the rest of it. But yeah,
I do like
the other stuff you got in motion.
It's just that I
Always going, bro. Stop working.
Quite often that I don't sell anything that I don't want to put in my car. Very simple.
Yeah. Oh, look, I rate it. I reckon even just the brace for the coil packs, man, it's super light. You've obviously come into development where it's not going to hold heat. Like I've seen some like brackets out there, and they just get hot because it's just a solid piece of, a billet or whatever they're made out of, and you've literally just gone to the next level and just gone, okay, let's chuck some holes in there, make it lighter, and access to getting the plugs out. Even waterproof, bro. Like that cooked me. Like he's like, oh look, I've even just made these cylinders to go in. For example, people that invented bonnets.
When the rain comes
I've had that.
I've
It
seen
sucks.
many
You get caught out. Like I'm out nearly every weekend. Doesn't matter if it's rain, hail, shine, whatever. I try to get out. We had a 33, and it had some Vertex bonnet on it, whatever. And some got in it, even though I kind of covered it with towel. It still got in there, and it just started misfiring. I'm like, sick. But obviously that will help a lot. Like I've washed this, bro, and the seal at the back. It doesn't work that great. I've literally had the channel full of water in there. I'm like, that's not good. I've got obviously the air gun blowing it out, and there's no water's actually physically got into the plug. So
And
good
that's,
design.
that's the trend. I thought that, when I usually design a product, I usually, go through, put different hats on. What is a user hat? I'm going to wash my car.
Yeah.
I just go rainwater, because it happened to me too. And I could put a tuner's hat on. Can I access the plug directly?
Yep.
Yeah.
And I put a reliable hat on. Am I getting quick connections? Am I getting a lock? Am I able to slide it out? Is the plug durable? Is the plug easily accessible?
Yeah.
There's a lot of questions flowing in my head, even before I pull up a cat file.
Yeah.
Nothing worse trying to pull out a whole bracket when it's like just done a power run on the dyno.
Yeah.
At least you can pull out, the plug that you think's failing instead of doing the whole rack, pulling the strut brace off if you have to, depending on what setup's on the car.
So, okay, so I'm going to jump on this Motec ECU. Now, obviously I had different ECUs in my life, many different brands. This is the first time I had Motec in my cars. I've been hearing a lot about Motec ECU, and can you, as a tuner, would you recommend this over? You tune vastly different ECUs. Why would you choose the Motec, or would you choose the Motec?
Obviously, I am biased because I'm a Motec dealer, but that aside, I'll speak honestly. So,
To you.
One of my first things back talking about 15, 20 years ago when we were talking Motec, it used to be, my biggest thing was on other ECUs is, can you ring the tech line right now and get an answer? And for most of those Wolfs, even Heltecs and that at the time, no, you couldn't. You had to wait and all that, whereas Motec had the technical staff there that would answer, and obviously they have some busy times and stuff, but over the years, that's the one thing. You've always got someone to talk to answer a question, and in business, time's money. So if I've got a car on the dyno, if I've got to wait 2 hours, that's 2 hours I don't make on the dyno. So that was one of the original things. Obviously, you've been with Motec, and what I was talking about before is it's the trust in the product, the accuracy, knowing how accurate. I have seen other ECUs, I won't mention brands, but like when you put a +2 overall ignition trim, it actually puts a +5 in.
Damn.
But
dangerous.
Yeah, it is. So there's been other things in software that aren't right. So Motec's always been good. They're constantly in development with software and products, and over the years the steps and there's I tune all ECUs. So I tune all ECUs. If you bring me an ECU that you've bought somewhere else, I will install it generally on a thing. But my preference is definitely a Motec. I'll always try and sell you into Motec, give you the reasons. But that's not to say, obviously, everyone does have a budget.
Of course.
Sometimes Motec is dearer, sometimes it's on par or even cheaper in some circumstances.
Black Friday sales, brother, get on them.
Yeah.
I'm not sure Motec does that though. I'm gonna have to ask them tomorrow then.
But yeah, Motec. But I won't count. There's a lot, like if you look at the desktop on my tuning laptop.
Yeah.
I think it was you that commented
more.
on it.
It's more.
The amount of different software I have from everything, from all the European stuff, the Australian stuff, the American stuff. There's so much there.
I can tell you, it's more than you going to city Christmas lights. The amount of software.
Yeah, but it is. But on paper, a lot of the time, they all kind of say they do the same thing. But I know that some of them don't do everything they say, or they don't do it well. With Motec, everything they say it does, and it does it well. And now the configurability of it, mind you, you need to learn to use M1 build and stuff.
It is quite a complex software.
The average tuner that knows how to tune a combustion engine isn't going to be able to go in and use M1 build. It's more a software programmer style rather than a tuner.
Yep. It's like a C++ base, is that the case? Is that C language?
It's kind of like a real cut down version of C.
Yeah, okay.
So it's got, like playing with M1 build, it's fascinating, right? Because it allows and not many people use M1 Build because most will just use M1 Tune with a ready package. But yeah, it's a great piece of software because it's kind of like this cut down version of C. It gives you a little bit of a playground, so you don't completely get yourself lost. But mate, it takes a fair bit of talent to actually use it properly, though.
Yeah.
Yeah, not only is a bachelor on that. Let's move on.
Yeah.
So okay,
But my recommendation is definitely the Motec.
of course, and I do trust you. And with your expertise, I do, and especially as a product development partner for this platform.
Yeah.
And I do appreciate your honest suggestion all the time, no matter when, and you always take care. You're always putting my hats on. Put it this way, and care about, try to fail safe my journey, and then I really appreciate that input from your
thank you.
expertise.
Yep.
Now, so we just recently did a plug and play for this M150. Now, what you just tuned on that car? What's your thought on that?
So that's great, and Motec are getting better at it, but that was some of the other brands like Heltec, particularly back 10 years ago. One of the good things they had was plug and play units with adapter looms and stuff. Motec did it in the higher grade stuff with specific motorsport requests, like with Group N rally and stuff with OEM plug-in units. So where it was needed for a specific set of rules in a race car category, Motec did it. But they kind of left the other adapter looms and us as dealers to wire it in. And it just brought the costs up a little bit. And I suppose the complexity that not all workshops could then fit a Motec. Motec are getting very good with plug-in units now, and obviously their dealer network and this M1 Build where workshops are able to produce their own packages and their own plug-in wiring and stuff. The cars that they can do now as a plug-in unit is getting more and more. But yeah, so that was, obviously you wanted a plug-in unit. There's value in GTRs now, so you don't want to go just changing everything. You kind of want to always have that thing of, I want to put it back to concourse.
Yeah, that's exactly the philosophy we actually carry on. We actually look at every single element and utilize what's already in the car.
Yeah.
Rather than let's chop half of it and we build it.
Yeah.
And that's not our philosophy. Our philosophy is sticking with the twin turbo, sticking with the simple setup, try to keep the heritage, the elegance of the car, while building modern technology into the platform and making it safe and also powerful, but while still keeping the heritage of the brand.
I just love it how you can run all modern stuff like ECU, packs, trigger kits and stuff like that, and get stupid power out of old, dinosaur turbos where back then everyone's like, you're not going to get any more than this. And then you're making like nearly, 80 kilowatts to 100 more than what you're doing 15 years ago with bugger all difference, not really opening up the motor, just bolt-ons. It's just tech.
So just quiet.
It's impressive.
Just shock. After we put the
that test, man,
after we did the core kit, and obviously we did
just physically even listening to the sound of you brought it
I
up as well.
Brought it up first time it ran up.
Just the note, you can just hear the crisp changing in plugs and the plug gapping and the coil pack. If I played the video back to back, because I filmed it, and the note just sounds different. It just sounds cleaner. And you notice obviously the fumes and stuff are coming out the back. It's not sooty anymore. It's burning a lot more of that.
Yeah, it also comes down to our approach to the product and how approach to run internal combustion engine. We understand that there's plenty of guys out there making massive powers with massive turbos, but we just think that there's a need to run things in a more efficient way.
Not everyone could just go build even afford 1,000 horsepower. So you got to cater for the middle class as well, where like myself can only afford twin turbos at the moment.
Middle class.
I had 1150 horsepower and I broke it, so now I'm back to middle class. So I mean, these bolt-ons make it easier for me to not get stabbed by the missus for one, seeing the bank account just go, where the fuck did Bill's block come from, man? Nah, so like it's good in that sense. Like you go to a car meet these days, like I'm out like every weekend really. Majority of the cars are still twin turbo.
Yeah.
And it's gangster. I mean, like I froth it. It's I love that old school OEM. Like
Yeah, I do
vibe.
like the twin turbo setup.
Yeah, singles are gangster. Don't get me wrong. It's sick. You hear something come on, like sequential going down, like 1,000 horsepower. It's just like wah, 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 and you're just like, that sounds awesome. That's sick. And you're like, I wish I could have that, but I mean, a house is cool too. So obviously the twin turbo thing, it's fun. It's zippy still. You can still have a lot of fun on the street legally. Yeah. To a point. And I mean, like, again, you're getting pulled over. I had that literally scenario. I got pulled over by this, like, awesome cop. It was amazing. Not really. Anyway, he asked me for the fuel rail because he couldn't pick anything else. He's looking for, like, everything. Screamers, whatnot. And he goes, oh, yeah, it's got pod fills. I'm like, yeah, can I have one air intake mod, but whatever. And he couldn't pick anything. He asked me on the fuel rail. That was about it. Is what it is. I mean, fair enough. Like, I'll just put the 30-year-old rusty fuel rail back on, and might catch fire, but all good. I just upgraded it. But that was about it. If I've had a single turbo, man, I would have to revert all that. Like, it's not even worth your time, man.
Yeah,
So
I've seen plenty of those stories online.
everyone's had their fair share. Don't get me wrong, but each to their own. End of the day, that's my pitch on that. But like, I've got single as well. They're both fun. It's just cool listening to like. Getting steam trained by someone, especially when the thing's going cha cha cha, and you're just like, see you later, brother. But it's cool. It is what it is.
Okay. Well, I guess you got anything else
No,
to ask you? I think.
We'll tune back in when we put your new Thundercore pack in. Once it's on the market, brother.
Well, yes, yeah, we just released. We did the test on the Thunder a couple of occasions.
That's why I turned to test and see what we break.
Well, this wing was from a different world, but it's from a different world in the way that we were expecting the game, but nowhere near compared to what we've seen, and it just once again satisfying to see our chain of thought, our approach, our philosophy is actually seeing the result, and that moment is epic. It's just epic, and I love to share more of that in the future in terms of the VVT system.
Oh man, that's gonna be a game changer.
The
VVT with like
VVT system, the dual VVT with the Multec system.
with a 1.6 gap. I mean, I want to see what that limit is to trying to blow the spark out. Like, you'd probably want to see it as well, where you can blow it out, where its limit is. So,
I tried with retarding timing, which simulates that, and I couldn't blow it out on the 1.6, but that's not to say we weren't running extreme boost
crazy,
levels.
yeah.
But
I mean, the only way to do it is like throw 70 PSI into it.
Well, I think there's only one way to find out, isn't it?
I'll get me Ryby vacuum out and we'll see what we can do.
I think just to wrap up the show, I think once again, thanks for everyone to attend.
That's cool.
And this is the first show, and I hope everyone enjoys the talk, and that there's a lot of knowledge sharing around, and I hope everyone learns something about it. I learned something about it today, so thanks again. You got something to add?
No, let's not break anything when we try this out, huh? See some numbers, hurt some egos. Let's do it.
Let's do it.
Cool. All right.
All right. Thank you.
thanks, guys.
Thanks, guys. See you later.